1 second. अभी भी नहीं आ रहा है. हाँ अभी आ गया. थैंक यू. Hi, hello everyone, hello. So sorry, there was some technical glitch. I was trying to start the live from few minutes. How are you? Hi everyone, hello. How is your preparation going? Did you revise all the 2-3 marker questions that we did in the morning? Hi, good afternoon everyone. Good afternoon Ambu, good vibes, Jia. Did you revise all the questions? Right, so today now I haven't written anything, but we are going to do, as the thumbnail suggests, we are going to do derivations, plus we are going to do all the important numericals. Okay, we'll look at those very quickly, okay, because we have a little bit less of a time. Okay, so we'll go through them very quickly. Done everyone? We'll go through them quickly. Now you want me to go quickly or you want me to take it a little bit slow? Good afternoon Aishwarya. Yes, we'll do the numericals. Okay, so can we start? We will start with the derivations. Okay, I've sent you the notes. I sent you the notes. No? Notes, you didn't receive the notes. Okay, let me just ask them. Yeah, I'll ask them and we'll send you the notes, don't worry. Okay, let us start with the derivations. Okay, we'll go with depends on you, Tanushri. How, if you want me to go quickly, we'll go quickly, and if you want me to go slow, we'll go slow. So realization will be in morning 5 or evening 5. This is in the evening. Let me see. Today's will be, it's 5 p.m. today's evening. Okay, so don't worry, let's start with the derivations first. Okay, we are getting so many answers off quickly. Done. We are going to see all the derivations very quickly. You have done it, we'll just revise it again, all the important derivations. Okay, let's start with the very first one. See, derive an expression for the electric field at a point, wait, due to an infinitely long, thin, uniformly charged straight wire. Infinitely long, thin, uniformly charged straight wire. Understood? Using Gauss's law. Now we just studied Gauss's law, right? So first, how you will start? You will start with Gauss's law as well. So we studied that phi equals to q by epsilon naught. Right, that is our Gauss's law, right? So you'll write Gauss's law. Now phi is closed interval of E dot ds. Done. So we'll write E dot ds, and its closed interval equals to q enclosed by epsilon naught. Now q, my friend, we know that q equals to linear charge density into its length, right? So can I write q enclosed into lambda into L? Why we wrote lambda into L? Because we have a long charge. It's not just a point charge. The charge is distributed over the whole straight wire. So we have to use, whenever there is not a point charge, the charge is all throughout the sphere or throughout the wire. So you have to use linear charge density, surface charge density, or volume charge density as required by the question. Okay? Yes, by doing these numericals, these are all the kinds of numericals I took. Okay, so by doing these numericals, you should be able to do the numericals very properly. Okay. Okay, done. Now you used Gauss law because it's written that we have to use Gauss law. Now the first thing in Gauss law is you have to create a Gaussian surface. Now in a straight wire, we know Gaussian surface is its cylinder around it. Gaussian surface is the cylinder around it. Done. So Gaussian, we'll do the numericals, don't worry. First we'll do derivations, then only you will jump to numericals, right? So this is a what do you say, cylinder I drew, right? This is a cylinder I drew, and what do you see? Now we'll take a small area, small length element, okay, small element. From there electric field is perpendicularly outwards. Now this is kind of an equipotential surface, and we know electric field on an equipotential surface is perpendicularly outwards, right? So it is perpendicularly outwards. So on this here, the distance, the angle between E and R, the angle will be 0 degree, right? But angle here the magnetic field is like this, electric field is like this. So theta is 90 degrees, and we are using E dot ds. Now let's see. Due to symmetry, E is constant on curved surface. This is curved surface, okay? E is constant on curved surface, but on top and bottom both E will be 0. Both E will be 0. So E dot ds equals to lambda L by epsilon naught. Till here we are clear? Now E dot ds for top and bottom is 0. Now for curved surface area of cylindrical is what? 2 pi RL. So you will write E, and this whole is 2 pi RL equals to lambda L by epsilon naught, and now you will take this term in here in the denominator and you just solve this. The final answer comes out to be 1 by 4 pi epsilon naught 2 lambda by R. Clear? Yes, these definitions, there are high chances that these definitions will appear in your exams. Okay? Done. The first whole derivation is complete. If they are given an infinitely long straight wire, this is how you will solve it. Okay? Okay, let's move on to the next. We have derived the expression for electric field at a point on the axis of an electric dipole. We are now asked to find the electric field at a point on the axis of an electric dipole. So if I make a dipole, minus q, this is plus q, this is the line joining between them, right? Now I have to find axis, the point on the axis, right? So how will we start? We'll take one random point somewhere here, let's say, okay? So R plus L. Yeah, so let's say this is a point P where I have to find the electric field. Now this distance, the distance from the center of the dipole to the point, this distance is L. Okay, this distance is L, and this whole distance between them is R. Done? Okay everyone, now what you have to see, from plus charge, electric field will be what? KQ divided by R minus L. Oh, this R is still the P, this R is still the P. Okay, let me just see, we have 2L here. See, this part is L and this part is also L. So for Q to P, where will you do? Proper length minus this whole L, right? Minus, wait a second, this is L. So this R minus L will be the distance between plus Q and P. This will be R minus L. Done? Now that is my electric field due to positive charge. If for this, I'll have the electric field as R plus L, right? So now net electric field will be plus electric field due to plus charge minus electric field due to minus charge. Done? Yeah, let me see. Let me open another PPT. Just wait for a second. This is not right. Let me open another PPT, guys. 1 second. Just a second, guys. Import. Yeah, we'll do it from this one. That PPT was made in bit of a hurry because we don't have much time. So we'll do with this one only. Okay, there are a bit of a mistakes in that PPT, so don't worry. See, now this is my electric dipole, plus Q and minus Q. Okay, this is a previous PPT, we didn't have much time. So this is minus Q, right? And this is plus Q. Done? And this is a point where we have to find the electric field. Done? Now the distance between these two, distance between the dipole, This is minus q, this is plus q. Distance between the dipole is what? Distance between the dipole is 2L. Okay, it is 2L. And the distance from the center of the dipole to a point where we have to find, that is, my friend, R. Right? If this is 2L, this will be L, this will also be L. Done? Now let's see quickly. Now, let's see. Now, plus q, kq by r minus l square. R is this complete and this is L. So, this complete from here, let me show you. This here, R minus L. So, from plus q, the distance will be r minus L. From minus q, the distance will be r plus L. Understood this whole diagram? How can we get by only studying this? It's fine, just follow on this, just study this, after that we'll see, you will get good marks. Done? Okay, so plus q is done, minus q, the distance is, this is same, kq by r square. Now the distance is r plus l square for minus q, right? For minus q. So this is what we got, like this till here we had the work. After that, it's just math, it's just normal calculation. Okay, so E net will be E plus minus E of negative. So of course they are of same magnitude, so E plus will have more strength of electric field, right? So E plus minus E of negative charge. So KQ by R minus L square minus of KQ by R plus L square. We are just going to solve that very easily. What do you see? You will see LCM R minus L into R plus L, the whole square. Right? So you'll take the LCM, here we'll get R plus L whole square, that is this, minus R minus L whole square. Done? And KQ we took it common. It is better if you take everything common. Done? Yeah, we'll do that, Madhu. I have that question as well, don't worry. Okay? Okay, now KQ is common. If you solve this, R square plus L square plus 2RL minus R square minus L square plus 2RL. So that plus 2RL got added up and we have 4RL. Okay? Hi Ambu. Done? Understood? We are doing derivations, and from here this is A minus B, A plus B, A square minus B square. If we had whole square, so we put the whole square here. Done? So KQ into 4RL divided by R square minus L square, the whole square. Done? Now you just have to solve this. We took K 4QL. If I write this Q inside, that will become 4QRL. Now what is the actual dipole moment? Dipole moment is the length between them and here the length between them, that is 2L into the charge. So 2QL. Out of this 4QL, can I write 2QL as P? So this will become 2 into P, and this R was extra. So I'll keep this R here. Done? So now we have just a random specific case if R is greater than L. Okay? Okay, Sarita, that is great. We hope that we provide you enough information, okay? Okay, so if R is greater, we'll just neglect this L square. This will become R4. This R and R4 gets cancelled. See, this R4 and this R gets cancelled. In the denominator, we just have R cube. Done? So E net will be 1 by 4 pi epsilon naught, that is K into 2P divided by R cube. So E net for this will be what? 1 by 4 pi epsilon naught divided by R cube into P. Okay? Into P, 2P, sorry. We have 2P. Done? Anyone has any doubt in this? Anyone has any doubt in this, or we'll move to the next derivation? Okay? Yeah, if you do all the model papers, you will easily get good marks. Okay, let's move on to the next. We have we have derived the expression for the electric field at a point on the equatorial plane of an electric dipole. So see, this is my electric dipole. Let's just make this diagram again, because diagrams are very important. Okay? Yes, Kavita, I'll provide the PDF of this chapter, don't worry. all these derivations. I hope that Suhana. Okay, let's see, let's make the diagram. Okay, so we have plus q dipole and we have minus q dipole. Now they have asked for equatorial line. Equatorial line is like this. So this is something of an equatorial line. This is something of an equatorial line. Done? Now, if I join these two dipoles, they will be joined something like this, right? Great. Now, what you have to do on this equatorial line from these dipoles, there will be some force. So, this minus q, the electric field will be towards minus q, right? So, this will be here, right? This will be here, and due to plus q, it will be in the opposite direction. It will be in the opposite direction like this. E due to plus q, E due to minus q, right? Now let's see what happens. Okay, we can also, this is theta, this is theta, then this angle, these angles will also be theta. Okay, done? Right. Let's see now, along the direction of the electric field will cancel. What happens when you say that this is the electric field? Of course, it's theta. We will, the first thing we'll do, will break them into their components, the x component and y component. Now the x component, both of them will point in this direction. Both of them will point in right hand side or in positive x direction, due to minus q as well, due to plus q as well. Okay, and the y component, one will be above, this component will be above, and this component will be down, so they will get cancelled. So y components gets cancelled and x components we add up, right? Now due to plus E, due to plus charge, for plus charge it will be kq by r dash square. This is r dash square. This is r dash, this is also r dash, and this is simply r. Okay, now distance between q and this point, that is r dash, so I write r dash square. Then, and E minus is also equal, so let's say we call them E. Done. Now E net will be Ex plus Ex because they are both in the same direction. Done. Model question paper numericals, Aditi, we have already solved. They are on the channel, you can go watch them. Even in this live, we'll do the numericals, they are picked from those model question papers as well. Okay? Okay. Now see, if this is E, the component in the x direction, if theta is here, this will be E cos theta, right? And due to this one, it will also be E cos theta. So we will add the two E cos thetas. E cos theta plus E cos theta, that is 2 E cos theta. So that is E is what? KQ by R prime square. Done. So this is 2KQ divided by R dash or R prime, you call it, square, into cos theta we already have, right? This is E of net. Now what you do, you'll just have to solve it. Now theta, cos theta, we don't want it in right, our answer. So what we'll do is, we'll find cos theta from here. Cos theta is base upon hypotenuse, so that is L divided by my R dash. Now R dash is what? We can use Pythagoras theorem, R square plus L square, the under root, R square plus L square under root. Done? So this is my cos theta base upon hypotenuse. Base upon hypotenuse, that is my cos theta. Done. Now this is K 2QL into R square plus L square. If you add this, this is 1 plus 1 by 2, it becomes 3 by 2, right? And if you solve this, now 2QL, we already saw that P equals to charge into distance between the dipole. So this is, where did it go? 2QL. Done. and r square plus L square whole power 3 by 2. So K into P we wrote it, and r square plus L square 3 by 2. Now a specific case, if r is greater than L, that means the point is so far away. Now if I have asked you in the question that point is very far away, so in that case you have to do this case, r is greater than L. Okay, so r will remain, L we will neglect the L, so this will be r square into 3 by 2. So 2 and 2 cancels, this 2 and 2 cancels, only remains r cube. So the final answer becomes 1 by 4 pi epsilon naught p by r cube. Done? So final answer is 1 by 4 pi epsilon naught p by r cube. Done? Any doubt, anyone? These all are very important derivations, so you should not miss these. Okay? Okay, let's move on to the next. We have using Gauss's law. Again we have Gauss law, so you know that Gauss law is very important. Okay, so using Gauss law, arrive at the expression for electric field. First, there go. One rule I have whenever we solve questions is you read as you write. As you read the question, as you read a derivation, you just write that, okay, I have to find electric field at a point outside the charged spherical conducting shell. So you will make a charged spherical conducting shell. Also write the expression for electric field at a point on the surface and at a point that is outside the charged spherical conducting shell. So what will we see? We'll see, let us, we made a spherical Gaussian surface around that spherical shell first. So first thing you know in a Gauss law, while doing Gauss law, the first step is to make a Gaussian surface. Right? So what we did, we made a spherical Gaussian surface around this spherical conducting shell. Okay, now the radius we took till here, the radius is r. It is the radius of spherical shell is capital R. The distance of this Gaussian surface, the spherical radius of this Gaussian surface will be small r. Okay, done. So again E dot ds equals to q by epsilon naught. That is clear. Now next thing we know, second thing you have to do is write the Gauss law, then write q in the form of their charge density. Whether it is surface or whether it is linear. So first thing you wrote Gauss law, you made the Gaussian surface, wrote the Gauss law, then write q in the form of the linear charge density or surface charge density. So in here we are definitely seeing that it's a sphere, so we'll write the surface charge density. That is what? Sigma equals to q by surface area of this sphere, that is 4 pi r square. So q will be 4 pi r square into sigma. Now due to this spherical symmetry, E is constant on the surface, that we know. So E into ds equals to q by epsilon naught. Q is 4 pi r square into sigma. So if you find this, you'll put 4 pi r square into sigma, this 4 pi cancels out, E comes out to be sigma r square divided by r square into epsilon naught. Now this r square is the radius of our spherical shell, this r square is the radius of Gaussian surface. Okay, done everyone? Any doubt? Okay, so E surface. Now we have to find, they've said that a specific phase, yeah, whatever. So at a point on the surface of the same charged spherical shell. Now not here, we don't have to find the electric field here, but on this surface. So this r becomes equal to r, small r becomes equal to capital R, right? So the small r becomes equal to capital R, and this cancels out, and that will be sigma by epsilon naught. Okay, done? I don't understand. Ambu, can you please write in English? Any doubt in this question? Any doubt in this question, everyone? Okay, let's move to the next one. Okay, let's move to the next part. Next derivation we have derive at the expression for electric potential at a point due to a point source charge. So read this question very carefully. Derive the expression for electric potential. So first we have to find the derivation of, we have to find derive derivation. Okay, last step C, my friend, in the last step they have clearly asked us also write the expression of electric field at a point on the surface of the same charged spherical shell. That means this, we don't have to find the electric field here now, we have to find it on the on our spherical surface, right? So its radius is given as r, right? So this r, this small r is the distance of the Gaussian surface from the center. This becomes equal to capital R. So I've put capital R here as well. If I put r square here, this 2 cancels out and it comes out to be sigma by epsilon naught. Done? These are all almost 5 marker derivations. Okay? This I explained the last step again. Okay? Okay, let's move on to the next. We have expression for electric potential at a point due to a point source charge. So this is my point source charge. Okay, this is my point source charge, that is plus q. Now I have another charge and I have to find the electric potential. So what is the electric potential? I have to do a work done to bring this charge from infinity to a point P. To a point P. The charge is somewhere and I have to bring that charge to the point P. So what is the electric potential in that? Okay, if you write only this much, see, this is derivation. You have to explain the diagram. You have to write that let a charge is at plus q and let another charge, a test charge somewhere, and we have to bring that charge at point P. So if you write all that, you'll get good marks. Okay. Hi, Fazal. Hello. Okay. Now, first thing first, what you have to do, you have to, for the potential you need work done. Now for work done you need force, and in between two charges you can easily find force. So let's find the force. So force is simply kq into plus 1. What is this? This is source charge and that is my test charge. So kq, that is q into plus 1. So k q1 into q2 divided by r square. Right, and this will be my correct formula, that is k into q into plus 1 divided by the distance between them. Till here at any point B we have the distance as x, so we'll write x. Now just leave this whole part. If my, let's say, just remember that, see, there is a plus q charge and you are bringing another plus q charge near that plus q charge. So they will repel, obviously. So the force will be negative. So force will be negative, that will, so force becomes minus kq divided by x square. Kq divided by x square. Right? Now work done is what? Force into displacement. So let's say it displaced by a dx amount. So that is force into displacement. So this is kq divided by x square. This is q, capital Q. Okay. So this is kq by x square into dx. Now since this is for the small part, we have to integrate it. So we'll have to integrate from infinity to this point P. That is the distance r. Right, so we'll put the limits as infinity to p, that is r, and dw we'll write minus kqx by x square into dx. After that it's just normal integration, right? Minus kq minus 1 by x, and the limits are r to infinity, that will be 1 by r minus 1 by infinity into kq if you take this minus out. Right, and the final answer will be kq divided by r, and you can write k as 1 by 4 pi epsilon naught q by r. Yes, this is very important. Okay, let's move on to the next derivation. Done? Anyone has any doubt? Anyone has any doubt? Okay, let's move on to the next derivation. We are jumping on to some torque. Okay. Now torque topic is very important. Okay. So Obtain an expression for potential energy. Again, what you have to find? Potential energy of an electric dipole placed in a uniform electric field. So an electric dipole minus q plus q placed in a uniform electric field. Okay? Great, great. Yes, yes, Saida, this is important. Okay, Mohi. Done. Now, you place the dipole at any angle, let's say minus q to plus q. Let's say you placed it at 90 degree or whatever, and it's placed in a uniform electric field. Done. So, what you have to do now, torque formula is dw equals to tau d theta. This is an important formula. Change in work done. Work done equals to tau into d theta. Right? Now, tau into d theta, tau will be what? For a dipole, tau is P sine theta. Tau is P cross E or P into E into sine theta for a dipole that is placed in an electric field. Okay? So, we will use this formula here, equals to Pe sine theta d theta. Now, work done or your energy will be from pi by 2 to theta. So, what we are saying that the dipole was first at 90 degrees. The dipole was aligned like this in the electric field. But after placing in the electric field, it got aligned to an angle theta. Done? It got aligned to an angle theta. Okay. Now, first, so the limits will be pi by 2 to theta. Done. Now, it's very simple. Sin theta integration is what? Minus cos theta. Limits are pi by 2 to theta. So, that will be cos of theta minus cos of pi by 2. And we took this minus outside. And this is just plain calculation. Minus Pe cos theta minus cos pi by 2 is 0. So, this is cos theta. Now, Pe cos theta is what? P dot E. Pe, do this, Varun, you'll pass. Okay, do all the questions I am doing here, you'll easily pass. So, U equals to minus P dot E. Done. So, this is the expression for potential energy of an electric dipole placed in a uniform electric field. Done, everyone? Now, they have just asked, define energy density of a charge capacitor. So, energy per unit volume is your energy density. So, total energy stored per unit volume, and its expression will be half epsilon naught E square. Right? Okay, let's move on to the next derivation. Assuming the expression for drift velocity, derive the expression for conductivity of a material, that is sigma equals to Ne square tau by m, where symbols have their usual meaning. So, they have already told you, ma'am, it is electric field, so P sin theta, right, but the derivation is of magnetic dipole, right. Which derivation is of magnetic dipole? We used everything, we used dipole moment P, right? Yeah, my throat is a bit bad. I'll drink water. Thank you. Done? Yes, if you have not studied the entire year and now you just want to quickly pass it, model question papers are enough. No worries. Okay, so they have told you to start with drift velocity. So, we'll start with drift velocity. Drift velocity is simply E, that is electronic charge, into electric field by m into tau, that is relaxation time. Done? So, E into E by m into tau, E tau by m. Okay, right after the derivations, we'll solve numericals, Aditi. Okay? Done. Now, we know that I equals to NEAVD. This is, we know, the current due to the electrons that are having drift velocity. Okay. So, I equals to NEAVD. So, J. Now, they are asking us to the expression for conductivity of a material, that is sigma. So, how we will go through it? First, what is J? J will be current by area. Right? J will be current by area. Done. So, that is NEAVD divided by A. If I divide this by A, so this gets cancelled. So, we get NE into VD. Now, J equals to NE into VD. We also have this formula. To start with, we started with this, right? So we put this formula here, E into tau by m. So NE square by m into tau into E. Now from Ohm's law, we know J equals to sigma E. Current density equals to sigma into E. Here current density equals to I by A. So we solved everything. From Ohm's law, we know J equals to sigma E. Yes, it's me, extreme. Model question papers are enough. Done. By comparing, we'll get sigma equals to NE square tau by m. Understood? Easy. Diagram for this one, you can skip it if you want, if you don't have time. But if you have time, make the diagram. It looks better. Done? Okay, let's move to the next. Next, we have derive an expression for effective EMF and effective internal resistance of two cells of different EMFs and internal resistances connected in series. Now, this is very easy. Very easy, right? So, we have two cells with EMF E1 and E2. Both have internal resistances R1 and R2. Now, here diagram is important. Okay? Yes, boss, I drank the water. No. If you write like this, I am not saying you'll get full marks, but we have to do quickly, so we are doing the derivations. You have to explain properly that let two cells of EMF E1 and E2 with their internal resistances R1 and R2 connected in series. A current is going, current I is passing through both of these, right? Yeah, we will come to Lensmaker's formula in some time. Don't worry, okay? We will come to Wheatstone bridge as well. Trust me, I have got you all the derivations, all the questions. Don't worry. Okay? Now, how you start with this is the first Kirchhoff's law, right? So, if you see in this whole loop, what will you say? First is I. I is passing the current, right? So, for this resistance, it will be I into R, right? Plus I into R2. Plus I into R2 and then plus I into R1 equals to the total EMF is E1 plus E2. Understood? This first equation understood everyone? So we just rearranged it. We took IR here, E1 plus E2 and we put this here. Right? We wrote this on the other side of equal sign minus I R1 plus R2. Now, in this circuit, what will happen in equivalent circuit? If I make an equivalent circuit, I will have one EMF, one in resistance and one external resistance and I current flowing through it. For this, what will be the Kirchhoff's law? I into R plus I into R equivalent equal to E equivalent. Done? Full wave rectifier, half wave rectifier, Wheatstone bridge, everything will cover, okay? Don't worry, prism also will cover, don't worry. So, I into R equals to E equivalent minus I into R equivalent. Done? We'll do the important numericals in some time, don't worry. So, comparing first and second, this first and this second. If we compare these two, E equivalent will be what? E1 plus E2. E equivalent is E1 plus E2. R equivalent will be what? R1 plus R2. R equivalent is R1 plus R2. Done? Done everyone? Okay, drift velocity 1. What, Krishna, in drift velocity 1, what do you want to ask? What do you want to ask? We'll do everything, Jia, we'll do everything, don't worry. Just have a little bit of patience and faith. What do you want me to do in the drift velocity 1, Krishna? Okay, until then you explain, let me know what you want me to explain and I'll explain that, okay? Now, next we have derive an expression for effective EMF. Now, remember this is the same question. That was in series, this is in parallel. So, very minor change you have to make. Kirchhoff's law we have to use. Okay, so in loop 1, in this loop, what you will do, I1 R1 plus I into R, this I into R, right? First loop is like this one. Okay, so I1 into R1 plus I into R equals to E1. Understood? In the first loop, it will be IR plus I1 into R1 equals to E1. Done? Then in the second loop, same I into R plus I2 into R2 now. Right? What? Ma'am, could you please tell me if it is okay when the question parts or question numbers come on the changes? For example, 21, again in the down I wrote 32. I didn't understand, sorry. Yes, it will be enough for the electrostatic potential. Just write the theory with it. Okay, we'll do the numericals in some time. Okay, now for loop 1 it's done, for loop 1 it's done, loop 2 is done. We got two expressions, I1 R1 plus IR equals to I1. So we'll just rearrange it. What we'll do, I1 R1, this IR will be sent there, I1 minus R, and this R1 will be in denominator, right? I1 minus R1. So first this expression came, I1 equals to E1 divided by R1 minus IR by R1. Similarly, this will be the exact case for loop 2. Done. This will be the exact case for loop 2, and for equivalent resistance for done. So the total current in parallel, we know current adds. Okay, in total, if see, it depends on the marks. You have to write the explanation. You have to explain where the all the formulas came from. You will get full marks. Don't worry for the drift velocity one. Okay, now I2 became, now in parallel we know I1 and I2 gets added up. So I will be I1 plus I2, and we'll add both of these, I2 by R2 plus I1 by E1 by R1 minus IR common 1 by R1 plus 1 by R2. Done. Now we just solved it. I term is here, E term minus I, and IR, this whole will be in the divide. So see, you have to write the EMF term differently and I term differently. Okay, so this whole term I1 1 by R1 plus 1 by R2 goes in the denominator of this first whole term and this second whole term. Okay, let's see. So when you do the division, 1 by R1 plus 1 by R2, this is the first term, and in the division you have 1 by R1 plus 1 by R2. Then the second term minus, you have I plus the second term 1 by R1 plus 1 by R2. Okay, then for equivalent circuit, if you equate the circuit just like we did before, it is simply E equivalent minus I into R equivalent, that is same. Now just equate it, E equivalent equals to E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2, and for R equivalent becomes 1 by R1 plus 1 by R2. Done? Why do you want me to remove the glasses? I can't see. Yes, this derivation is important. Both of these derivations, cells in series, cells in parallel, both of these are included in your model question papers. Okay? No. It is acceptable to change the order. Don't worry about that. Done? Okay, let's move to the next question. There, your Wheatstone bridge. This question, if on Wheatstone bridge any question come, this is that question. Okay, and 99% this exact same question will come. Okay. I don't recommend to like directly switch in between parts to write your answers. You are done with first part, go to the second, done with second part, go to the third. That's like basic, no? Good afternoon, Sanjana. Okay, now in the Wheatstone bridge, you will get one condition, that is balance condition. Arrive at the balance condition of Wheatstone bridge using Kirchhoff's law. So what you have to do, you have to just remember these two things. Condition is, first of all, Ig is 0. This Ig, the current in the center wire, Ig will be 0, and then I1 equals to I3. Now if Ig is 0, the current that is going into this will be the exact current that could go through in this wire as well, right? Similarly, the current that goes in I2 will be the current that goes in I4, because no current is going in Ig, right? So current in I1 will be equal to I3, current in I2 will be equal to I4. Then now we apply Kirchhoff's law in ABDA, first loop. So what will happen? I1 in I2 into R, yeah, you can do I1 into P plus 0 into G, I1 into P plus 0 into, this is G, 0 into G, okay, 0 into G minus, now this is in the opposite direction of current, this is I2, but we are going like this, so this is minus I2 into R, okay, equals to 0. Done? Okay, let me ask if they have sent the PDF first. Okay, I have asked them, they'll send you, okay? Okay, everyone, done? Passing package, Somek sir will come at 5 p.m. They'll handle that, okay? Don't worry. See, combining all 3 model papers, 30 to 50 numbers can easily come. It can vary, but you easily can think that 80%, 70% of paper can come from model question paper. That doesn't mean you don't do the other whole papers, but a lot of questions can come from model question paper, okay? Yeah, we'll be moving on to prism, don't worry. Done? So the first is done, I1 into P into O into G minus I2R equals to 0. So this is 0, I1P equals to I2R. So P by R equals to I2 by I1. Done. Next we'll do the same thing with B, C, D, B. This another loop. Okay. So in this, if you go like this, I1, I3 into Q, however you can go however, okay, plus I4S. If you want to go like this, you can go. If you want to go in this loop, you can go, whatever suits you, okay. So here we have done I4 into S in the direction of I4 current, I4 into S minus I3 into Q equals to 0, and this is 0 anyways, Ig into 0. So I4S equals to I3Q, and if you just solve it, this is I2 into S equals to I1 into Q. Why? Because I2 equals to I4, so I can write I2 in place of I4, and I3 equals to I1, so I can write I1 in place of I3. Correct? Okay, you understand, you know this by heart. We'll do the numerical stages, don't worry, we'll do the numericals after derivations, okay. Now till here anyone has any doubt? Okay, so if I divide it Q by S will be I2 by I1. So this is your first equation, this is your second equation, I2 by I1, P by R will be equal to Q by S, and that is, my friend, the condition of Wheatstone bridge. Now when you write in the paper, you completely write it. Let us make a wheat bridge. We have 4 resistances placed like this, and for the balance condition we know Ig equals to 0, and hence I1 equals to I3, I2 equals to I4, and then start the solution. Okay? Okay, done? Let's move on to the next derivation. We have, oh, this is a good one. You need to use a little bit of brain in here. right? Derive an expression for force per unit length. We have to derive an expression for force per unit length on two infinitely long thin parallel straight conductors carrying currents and hence define ampere. Okay, so first you have to do what? First they are asking you to find the force. Now to find a force which includes B, which includes magnetic field. Yeah, Shreya, what do you think? Let them be, okay? Just focus on derivations. Mic is on, Manu. Okay. Okay. Yes, these are the steps for these derivations. It's tough. What is tough, Sarita? Venki. Okay, now first thing you have to do, whenever there is a conductor current placed in it and you want to find force per unit length of infinitely long thin parallel conductors, okay, now we know because these two conductors in which currents are flowing, yes, theory is needed. You just have to write, let us assume two wires, the current is in the same direction, then we'll find the magnetic field. Okay, then when you are doing the steps, let us find the magnetic field using Fleming left hand rule, using Maxwell right hand thumb rule. Okay? Okay, so first what you have to do, we'll find a magnetic field. Now magnetic field on this wire will be due to the I1. We understood this, right? So magnetic field on 2, magnetic field, this is second wire and this is first wire. So magnetic field on 2 due to 1 will be what? Mu naught by 2 pi. That is the magnetic field due to a strong straight conductor, long straight conductor. Okay, this is so tough. Let me explain it. Everyone. Okay, so first you have to find the magnetic field. Now on this conductor the magnetic field will be because of this conductor. On 2 the magnetic field will be due to 1. So on 2 due to 1, right? So that will be mu naught by 2 pi I1 into D. You just have to remember this formula and this formula. Two formulas for this derivation, nothing else. Okay, I will Amaya, just let me complete this. No, voltmeter, ammeter will not come for 5 marks. Don't worry about that. They might be coming in 2-3 markers, okay? Okay, so B12, the magnetic field on 2 due to 1, that is mu naught by 2 pi, and I1, the one who is applying magnetic field will get the place in this formula. So B12 equals to mu naught by 2 pi into I1 into D. So force on 2 due to 1. Force on 2 with respect to 1, and in here magnetic field on 2 due to 1. Okay, now force on 2 due to 1 will be this magnetic field that is produced by the second into its length into its current, right? So current is I2, length is L. So F21 will simply mu naught by 2 pi I1 by D into I2 into L. So mu naught by 2 pi I1 into I2 divided by D into L. Then till here no doubt, right? F21. Now the problem comes how to find the direction. First you will be using right hand thumb rule. So this current is going up and this is inside and outside. So at here the magnetic field will be outside, right? And due to this the current is in, and on this wire due to the current is upwards, the curling of fingers will give the direction of magnetic field. So inside there will be a magnetic field due to 1 on 2, the magnetic field due to 2 on 1. Understood? Now force by using Fleming left hand rule. So current is in upward direction, B is inwards, so force is in the left hand side, that is F21. In here the magnetic field is outward, so this is what? So this is F12, force in right hand side direction. Understood? Now length is same, distance is same, so F12 will be equal to minus F12 because we just saw that they are pointing towards each other. So their sign will be, one of them will be negative. Okay? One of them will be negative. So F12 will be equal to F21, but their sign will be negative. Okay, understood? Next, B21. Now, I am explaining again in the other part. Okay. Now, B21 is on 1 due to 2. Magnetic field on 1 due to 2. Right? Magnetic field on 1 due to 2. So this is on 1 due to 2. That will be mu naught by 2 pi into I2 by d. Mu naught by 2 pi into I2 divided by distance between them, that is d. Okay. Now F12, that is force on 1 due to 2. Force on 1 due to 2. Understood? So due to 2, the magnetic field is B21. So that is B21, the current of I1 into length of first conductor. Okay? Yes, we just did the derivation, Purva. Dipole, electric field for a dipole on its axis on an equatorial. We did both. You can go watch that. Okay? Okay. So mu naught by 2 pi I2 into d, we filled the value of B21 into I1 into L. Same formula will come. The magnitude is same, but the difference, the distance, the direction will be different. Right? So F will be mu naught by 2 pi I1 into I2 divided by d into L. Right? Now we have to find, very important part, we have to find force per unit length. So we will divide this length here, F by L will be what? Mu naught by 2 pi I1 into I2 into d. You will cross this length. Okay? You will cross this length. This will be F by L. There will be no length in the final question. Okay? Okay, so I1 equals to I2. If I1 is equal to I2 equals to 1 ampere, if d is 1 meter, then mu by 2 pi will be your complete answer. That will be 2 into 10 raised to power minus 7 Newton per meter. Okay, understood. What did you not understand, Aditi? Sorry for that. Done. Now let's see to explain ampere. Ampere is the current which flows through each of the two parallel wires, parallel conductors, kept at a distance of 1 meter, kept at a distance of this 1 meter, experiences 2 into 10 raised to power minus 7 Newton per meter force. Done? Okay. What did you not understand, Aditi? What do you want me to explain again? Oof. Oh, Ayan is getting 70 on 70 tomorrow. Best of luck. My Ashirwad is with you. Okay, let me just explain one more time. Okay. Okay. These are two wires, okay, and these are parallel. The current is in same direction. So I1, this is I2. Let's say, okay. Now the first thing you need to do is to find the direction of magnetic field. Now on I1, the magnetic field will be produced by 2. This is 2, this is 1. On first wire, the magnetic field will be produced by this second wire, right? So we will write that as B21. That is B on 1 due to 2, right? So this goes in it. The right hand thumb rule, thumb is in upward direction, curling of fingers, it's going in, it's going inside the plane. So in here it will go inside the plane, that is B21. Okay, understood? Yes, we'll do some problems. I'm explaining again. Listen. Okay, then magnetic field on 2 due to 1. Magnetic field on 2 due to 1. So that will be B12, right? So it is in the upward direction, curling of fingers, it's coming out. From this direction towards I1, it's coming out. So this magnetic field will be in this direction, that is B12. right? Understood everyone? Now you will be using Fleming left hand rule. So Fleming left hand rule, you have current, you have magnetic field, you will find the force. So current will be given by your middle finger, index finger will give the magnetic field. So something like this you will have, something like this you will have current in upward direction, magnetic field in inside the plane, and this is the force. This will be the force, that is F on 2 on 1 due to 2. Okay, now for this the magnetic field is not in this direction, it is in the outward direction. So force in this direction, force will be in this direction, force on 2 due to 1. Understood? So if they are in opposite directions, they will be negative of each other. That means F21 is equal to minus of F12, but their magnitude will be same. Done? Okay, very good. Let's move on to the next derivation. Next we have derive the expression for the magnetic field at a point on the axis of a circular current loop. So we'll do it very quickly. We have a circular current loop. First thing, you have to assume a length element here. Somewhere here we assumed a length element, that is called dl. From here we assumed a point that is x distance away on its axis. Okay, so from this is x distance, from this point, from dl, the length element, the distance is r. Okay, now the radius is capital R. So r will be what? R square plus x square under root, r square plus x square under root. Okay, now due to this it will be something like this, right? So we can break it in two parts, and due to this the magnetic field will be here, so we'll again break it in two components, that is x component and y component. Understood? Great, great. It's easy, you just want me to skip. Okay, let me just explain quickly. Okay, so what you will do now, this is an angle phi, this is an angle phi, so this angle will also be phi. So cos phi will be base upon hypotenuse r by small r, capital R by small r is r square plus x square, so we'll put that later on. Okay? Now for x axis we'll write dB cos theta, cos phi, and dB sin phi and dB sin phi. So these two components, y components gets cancelled, only the x component remains. So dBx will be dB cos phi. Now dB here will again be mu naught by 4 pi I dl divided by r square. This is the formula, you need to remember. We all know this, right? Mu naught by 4 pi I dl by r square due to a small element, length element. Okay, now cos phi was capital R divided by small r, cos phi was capital R divided by small r. So mu naught by 4 pi I into r divided by r cube into dl. So we wrote dl aside. Yes, direction of current is necessary. In the last question you are asking. Okay. Now this is dBx due to small length element. We need to calculate due to the whole current loop. So we will integrate it. Bx equals to integration over a closed loop dBx, that will be mu naught by 4 pi IR by cube, closed loop integration of dl. Now this whole circumference will be what? It will be 2 pi r simply, right? It will be 2 pi r. So instead of this whole integration of dl, we will just write 2 pi r. Simply. So this 4 pi and this 2 pi gets cancelled, we get 2 in the denominator. So mu naught by 2 IR square, this r is also there, right? So IR square divided by r cube. Done. Now this r cube, we know that r is in the form of r square plus x square. So in this r, we write r square plus x square. Now it has already 3 power, it has power 1 by 2. So that will become 3 by 2. Okay, for center, at the center x will be 0, at the center this x will be 0, right? So for x equals to 0, this becomes 0, r square, 2 and 2 get cancelled, it becomes r cube, and it becomes mu naught by 2 I into r square divided by r cube, right? So this cancels out, we get mu naught by 2 I by r. Done. I did explain ampere, Aditi. Here it's written, it might have stuck. So ampere is the current, according to this situation, is the current which flows through each of the two parallel conductors kept at a distance of 1 meter, experiencing a force of 2 into 10 raised to power minus Newton per meter, an electric field of 2 into 10 raised to power minus per meter. Okay, which derivation, Karina? We wrote Newton per meter here because in the question we are asked to find force per unit length. Okay? Which derivation, Karina? This one or the next one? Yes, yes. 5 marker derivations will come. It won't come from 5 marker questions, will not come from ray optics, from AC, from 1 or 2 more chapters. Let me look and see. Okay? Okay, let's move on to the next. We have deduce the lens maker's formula. Everyone knows this. This is easy. Yeah? Lens maker's formula is easy. Should I skip it or not? See, when you are explaining, just write what you know. Okay, you don't have to go through all the, if you don't know the scientific terms, so just write whatever you think is right in your normal English. Okay? Okay, should I skip this or not? You want me to explain this? This is easy. No, ma'am. Explain, ma'am. Okay. See, very easy. Just need to remember this formula. Now, you have a lens, right? So this is your object distance. Oops. This is your object distance, that is u, from the optical center. And this is your v, that is your image distance. Correct? That is your image distance. Correct? Yeah. So for the first, you just need to remember these two formulas. Okay, so N2 by V prime. N2 is the refractive index of the this side of the lens, and N1 is the refractive index of the this side of the lens, right? This part of the lens. So N2 by V prime. V prime is the image distance on the other side of the lens. N2 by V prime minus N1 by U. N1 by U. Right, equals to N2 minus N1, the difference of the refractive index, divided by R1, and for second N1 by V, for this N1 by V, right, N1 by V minus N2 by V prime, minus N2 divided by V prime, done, equals to N1 minus N2 by R2. So you just have to add these. What will you, these two gets cancelled, these two terms gets cancelled. So N1 by V minus N1 by U, N1 by V minus N1 by U equals to N2 minus N1 we can get common. If I get N2 minus N1 common from here, it will be minus 1 by R2. This is minus 1 by R2. So 1 by V minus 1 by U. This comes N1. We take N1 common from here, right? N1 common from here, and we take it in the denominator. So here is the N1 in the denominator. Okay, so N1 goes into the denominator. 1 by V minus 1 by U equals to N2 minus N2 by N1 minus 1 into 1 by R1 minus 1 by R2, right? Yes, you can say that because that kind of covers the whole syllabus. Okay, so your sir is correct. Done. Now if u equals to infinity, if the object is an infinity, then v will be equal to focal length, and v is equal to focal length, then what will happen? Then 1 by f minus 1 by infinity. V equals to focal length, so 1 by f equals to, this is infinity, so v 1 by infinity equals to n to 1. Can I write n2 by n1 as n to 1? So n to 1 minus 1, 1 by r1 minus 1 by r2. right? So the formula comes 1 by F equals to N to 1 minus 1 by R1 minus 1 by R2. Understood? Great. So we will get the marks for steps only. Yeah, you have to explain here that the image is formed, the refractive index of this part of the lens is N1, that is N2, all of that, okay? That's just theory. You just write what you are looking at, okay? Don't worry. Okay, let's move on to the next. Oh, prism, nice. So derive the expression for refractive index of the material of the prism in terms of angle of minimum deviation and angle of prism. This question was also in your model question paper. So this is important. I have solved those model question papers as well. If you want the complete solution, you can go. There's a playlist for model question paper. You can go solve all 3 model question papers available on the channel. Okay? Okay, now this question is very important. To derive the expression, we have a prism, right? So in this prism, this is your prism angle, that is A. This is your incident angle I and emergent angle E, right? Now in between, this is your R1, that is first refractive angle, R2, that is second refracted angle. Okay? Done? Now, what you need to start with, we know delta equals to I plus E minus A. Do you guys know that? What are you confused in, Sarita? Sorry. What are you confused in, Sarita? See, so delta equals to I plus E minus A, that is my prism angle. Now you can remember this because its derivation will include lots of geometry. If you want, I can tell, but I recommend you, this is just one question, so that you remember this I plus E minus A. It will be good. Okay? So when you start with that, from geometry, delta equals to I plus E minus A and A equals to R1 plus R2. Okay? Aditi, you can first of all do all the derivations, do all the numericals I'm doing, do all the 2 marker questions we did, and revise the model question papers. Those are enough to score good marks. Okay? And you should also be clear about the concepts, but these are enough. So now by observing I versus delta graph, this part you don't have to write much, but we can see that angle of minimum deviation. The angle of minimum deviation occurs when I equals to E and R1 is equal to R2. Delta is equal to I plus E. Delta is equal to I plus E minus A, not just I plus E. Okay? Delta will be equal to I plus E minus A as well. Okay, done everyone? So this statement, minimum deviation, we need minimum deviation. For minimum deviation, this is the condition. I should be equal to E, R1 should be equal to R2. This refracted, R1 equals to R2, I equals to E. Done? Now you just put these values in delta. Delta for minimum deviation equals to I plus E are equal. So they will become 2I minus A remains the same. So from here I comes as delta plus A divided by 2. Until here, any doubt? Until here. Done? No, from you can directly write that from geometry we know that delta equals to I plus E minus A. Don't worry. Okay? Then A equals to 2R. A equals to R1 plus R2. R1 and R2 are equal. So this will be 2R. So A equals to 2R. A equals to 2R. Done? Okay everyone? Diganath, that is from geometry. I recommend you to just remember it now, okay? Because you will have to go in this quadrilateral, A, Q, N, R. You will add A plus this whole part plus this whole part plus this one. Okay, so you will have to do all that calculation. Done? So you don't need to show it. You can directly write I plus E minus A. Okay? Done? Okay, so A equals to 2R and these two main things came. I equals to A plus delta M by 2 and A equals to 2R, which you can write R equals to A by 2. Now we know that we have a very important law that N to 1 equals to sin I by sin R. Right? The refractive index will be given by sin I by sin R. So we have I, we have R, just put these values. Sin into A plus delta M by 2, A plus delta M by 2, sin into R. For sin into R, we have A by 2, sin into A by 2. Understood? Okay, everyone, understood? Any doubt in this whole derivation? Okay. Just shut up and study. Okay. Let's move on to the next. Two coherent waves of same amplitude and constant phase difference undergo interference. Okay. Obtain an expression for resultant displacement and mention the two uses of Polaroids. That we know. You let me know what are the two uses of Polaroids. Until then I explain this derivation. Okay. Write down fast what are the two uses of Polaroids. For this you don't have to do anything. We know that y1, that is your difference, this y value, your amplitude will be A sin omega t. Right, and y2 will be A sin omega t plus phi, because we have two coherent waves and they can have some constant phase difference. So plus phi is their constant phase difference. Right, so y1 is A sin omega t, y2 is A sin omega t plus phi. Then phi is the phase difference. Now according to the superposition we have direct formula, that is y1 plus y2 for superposition. So we just add these, A sin omega t plus A sin omega t plus phi. So A, we took it common, sin omega t plus sin omega t plus phi, 2A, because sin plus sin gives us what? 2 sin A plus B by 2 cos A minus B by 2. Okay. So sin A plus B, omega t plus phi by 2 cos omega t minus phi by 2. Done, and this is the 2. So we took 2 out, 2A sin omega t plus phi by 2. This will be 2 omega t, 2 will get cancelled, plus 2 will remain in the denominator with phi only. Then cos, this will cancel out and this will remain minus phi by 2. Now cos minus theta is equal to cos theta. Right, so this will become 2A sin omega t plus phi by 2 and cos theta. So that will be 2A cos phi, sorry. So 2A cos phi by 2 plus sin omega t plus phi by 2. Now this will be your amplitude. Okay, this will be your resultant displacement. This whole will be your resultant displacement. Done. And we have the answer. They are used in car windows for reducing the intensity of light. Also they are used in goggles, right, again to reduce the intensity of lights. Okay, these are 5 marker questions, Aditi. So we'll do long questions first. Okay, 5 marker MCQs we have already covered. Done. Okay, now this question is important. How many of you do know the answer to this? How many of you do know how to solve this? Okay, so using Huygens principle, arrive at the law of reflection for a plane wave. Huygens principle basically says that your every point on your wavefront is a source for now secondary wavefront. Okay, so what we see is two rays are coming, and this is your mirror. Okay, so they are reflecting back because we want to see reflection. Okay, so these two rays are coming and they get reflected back. They get reflected back. Okay, this is your, wait a second, let me change the color. See, from here this is your reflected ray. These two rays are coming. Okay, these two rays are coming and this is your reflected ray. Now this is a normal, so this is angle I and this is your angle R. Now from here, from this point, we make a perpendicular to another ray with a, and this is of course now 90 degree. Okay, what? Explain again, explain again. Would you want me to explain again, everyone? The last question. Let me explain this question, then I'll explain the last question. Okay? Okay, okay, everyone. Okay, so here what we know that this BC, see, try to understand, when this ray is coming, this ray when reached this point, the perpendicularly opposite point, this ray already hit the ground and start reflecting. So when this ray reached at this point, this reflected ray reached at point D. So this AD will be equal to BC. Right? This AD will be equal to BC. Now, BC is V into T because it's traveling with speed V in time T. AD will also be V into T. So, BC equals to V into T, AD is V into T, BC equals to AD. Now, ABC in triangle ABC and triangle ABD. That is your triangle ABC and triangle ABD. ABD? It should be ADC. ACD. Okay. Now, BC is equal to AD. That we already know, right? Angle ABC equals to angle ADC. That is, those both are 90 degree. So, they are always equal. Now, AC is common. So, AC is common. Now, because these triangles are congruent, that is, triangle ABC is congruent to triangle ADC. So, that means my triangle BAC becomes equal to DCA. Becomes equal to DCA. That means angle I is equal to angle R. Done? That is your derivation. Okay? The last derivation. This. You want me to explain this one? This is easy. Which question you want me to explain? 15th or 14th? Let me know first. We just have 4 more derivations, then we'll go to numericals. Okay, everyone? Don't worry. This question, you don't have to do anything in this question. You know what is the definition, what is the formula for amplitude, right? See, two coherent waves of same amplitude. So, amplitude is same, right? Their displacement and constant phase difference, that is my phi, constant phase difference, undergo interference. Obtain an expression for resultant displacement. Now, for first ray, y1, that is how much distance it traveled, how much displacement, that is y1 equals to a sin omega t. Now, they have a constant phase difference. So, phase difference is phi. So, second will be y2 equals to a sin omega t plus phi because they have a phase difference. Okay. Now, according to superposition in interference, you will simply add these two, that is y1 plus y2, and you will get the resultant amplitude. This is your resultant amplitude. To find the resultant amplitude, this is the displacement. This is the total displacement, that will be y1 plus y2. Okay. So, we added up a sin omega t plus a sin omega t plus phi. right? Now we took common sin omega t plus sin omega t plus phi. This is the property, right? Sin plus sin is what? 2 sin cos, 2 sin a plus b by 2 cos a minus b by 2. So 2a, that is 2 sin a plus b, omega t plus phi divided by 2 into cos a minus b. So omega t minus phi divided by 2. Understood? So this is 2a sin 2 omega t, and if you will get this, right, 2 omega t by 2, so this will cancel up, plus phi by 2, the denominator under 5 remains, into cos minus phi by 2. This cancels out, the remaining is minus phi by 2, minus phi by 2. Now cos minus theta is cos theta, right? So 2a cos phi by 2, we took it here, and sin omega t plus phi by 2. Now this part 2a cos phi by 2 will be your resulting amplitude. Done? Understood? Any doubt? Okay, quickly let's move on to the next. We have 17th question. It's similar. I'm giving you this as homework. If you have any doubt, you can ask. Okay, this is similar to the reflection, but now not reflection, refraction is happening. So this BC will be equal to again AD, will be equal to again AD, but they are traveling with V2 speed and it is traveling in V1 speed. So BC equals to V1t, AD will be equal to V2t. Okay, so sin I will be what? This is I, right? So sin I will be perpendicular upon hypotenuse, BC divided by AC, BC divided by AC. Now BC is V1t, AC is AC. So sin R. Now how did R, this angle became R? See, using external angle property. So this 90 plus this angle 90 plus ACD will be equal to this whole angle, that is 90 plus R, that is 90 plus R. So this 90 cancels out, ACD becomes R. Done? ACD becomes R. So sin R is what? AD divided by AC, AD divided by AC, AD is what? V2t divided by AC. Done? Okay, sin I by sin R, just divide these two, you'll get the answer and you'll reach to Snell's law. Okay? Okay, let's move on to the next question. We have, what is a rectifier? Rectifier is an electronic device that converts alternating current into direct current. Okay, now positive half cycle, we have to explain the working of full wave rectifier. Now first understand the diagram of full wave rectifier. Okay, first we have a primary coil, then we have a secondary coil. This is same. In here, in the first you will have a diode, in the second you will have the diode pointing in the same direction. Okay, so this is D1, this is D2, and this is where we are taking the output from. Okay, now let's study the construction, the working during the positive half cycle. When the positive half cycle comes, it will come something like this: positive half cycle, negative half cycle. So when positive half cycle, D1 will become forward biased and the current will pass through it, but D2 will become negative biased and it will break, no current will pass through it. But in A, the current is passing and going through RL, so we'll get an output. Right? Similarly, when a negative cycle, during a negative cycle, this is negative, this is positive. Now D2 becomes forward biased, so current will be passing from B. So anyways, in any case, current is passing and that is what we care for. Okay, so through RL we are getting an output, that is what we care for. Done? 60 to 70% paper can come from a model paper. Okay, yes, question bank MCQs can come. Yes. Okay, now again I explained you the negative cycle. When the negative cycle comes, D1 becomes reverse biased, D2 becomes forward biased, current is still going through RL, and this is the output we'll get. If it's a positive cycle, still there is an output. If there is a negative cycle, still there is an output. Positive cycle, output due to D1, negative cycle, output due to D2. Understood? Okay, Next we have half wave rectifier. So in half wave rectifier is an electronic circuit that converts AC into DC, but by allowing current to flow only during one half cycle of the AC input signal, the other half cycle is blocked. So only half of the AC waveform is used. Okay. How will we do that? It's the same circuit, but this time we don't have any diode here. In the B part, we don't have any diode, right? That is the only difference between the diagram of full wave rectifier and half wave rectifier. So during the positive cycle, this positive cycle comes, negative comes, this D1 becomes forward biased and we get a current in RL. But during the negative cycle, this becomes reverse biased and there is no diode here. So we do not get any current in RL due to the negative cycle. We are going to do numericals in 2 minutes, okay? Ray optics, from ray optics no derivation will come, don't worry. The one we did was wave optics, was ray optics. Okay, you can, so if you want, but those derivations might come in 2 to 3 markers. I won't ask you to skip, just see it a little bit, because even if this time board decides to do something tricky with you, you are prepared. Okay, now construction is simply, you have 2 coils, you have a primary coil and a secondary coil, and they are placed very close together, and due to the mutual induction, current is flowing. So we are given an AC input from here, it passes from this coil, due to the mutual induction, current is produced here, and we have a whole lot of diodes here as well. Okay, now in negative cycle, during the negative cycle of the AC input, the P side of the diode, becomes negative with respect to N side. Yeah, so here negative comes, here positive comes. So this becomes reverse biased, so no current is flowing, right? This diode is reverse biased and does not conduct. No current flows through the load. There is no current in the load, right? So there is no output voltage. So for half wave rectifier, this current goes, the positive cycle we have output, but for negative cycle there is no output. Positive cycle output, negative cycle no output. Understood? Done? Yeah, according to the blueprint, they have actually told that from ray optics, there are high chances that you won't get any 5 marker derivations. Okay? Done? Okay. Next we have last question, that is write 3 differences between intrinsic semiconductor and extrinsic semiconductor. This is easy, I am guessing. A pure semiconductor with no impurities is intrinsic. Semiconductor with small amount or high amount of impurities is extrinsic semiconductor. To improve inductivity, we dope the semiconductors. Okay? Yeah, okay, let me explain the diagram. Here, intrinsic, we have equal numbers of holes and electrons. There, we have unequal number of holes and electrons. Sometimes electrons are more, electrons are less. For N-type, electrons are more. For P-type, electrons are less. Now, intrinsic have low conductivity, extrinsic have high conductivity due to increased number of charge carriers. Okay? We have, okay, diagram. See, in this diagram, this is the diagram of half wave rectifier. Okay? This is a diagram of half wave. So this is my primary coil, this is my secondary coil. From here we are giving an input AC input signal. Okay, the current flows, okay, and due to the mutual induction between 2 coils, current flows in here as well. Now in positive cycle this becomes forward biased, and in negative cycle this becomes reversed biased. In forward biased current flows, so in positive circle current is flowing. In negative cycle it becomes reverse biased, no current is flowing, so there is no output. Understood? Okay, let us see the numericals now. Let us see the numericals now. I'll have to, just give me 1 second. Let me Okay, we have the numericals from sir's slide as well because, yup, done. We don't have any time, so we are using the numericals that sir taught you, okay, because those are very important. We'll do the numericals quickly and we'll be done with this live, okay? Okay, let's start very fast. Very easy topic. Charges of plus 10 nanocoulomb, minus 20 nanocoulomb, minus 10, minus 20 again are placed at the corners of A, B, C, D of a square, respectively of side 0.05 meters. So it has 0.05 meter as a side. Calculate the resultant force on the charge D. Okay, this is very easy. This is simply we are going to use the force formula, that is K into Q1 into Q2 divided by R square. Now on D, due to force will be due to 1 and force will be due to B, force will be due to C. So we'll calculate all of these three and we'll see their resultant. Now first see, first what will happen, A is positive, B is negative, right? C is also negative. So in D, D is positive. So this will repel, A will repel, C will attract and B will also attract. Till here you understand? Right? Now first we'll calculate FA, that is K, Q1 into Q2. Q1 is QA, Q2 into QD divided by R square. So Q1 is QA, Q2 is QD divided by R square. R square is what? 0.05 meters. So this is 0.05 square. Now if you solve this, you will get the answer as 18.25 into 10 raised to the minus 3 Newton. Okay, force on D due to A. Now quickly, the C will be same. Force on C at D due to C at D will be same because it is also 10 nanocoulomb. It was also 10 nanocoulomb. So the force, the magnitude of force will also be same. 18 by 25, 10 raised to the minus 3 Newton. But this is repulsive, this is attractive. Done. Now first, before doing that, see, this is FA, this is FA, this is FC. So the resultant will be something like this and the angle between them is what? 90 degree. So what is the resultant? FAC equals to FA square plus FC square. Right? FA square plus FC square. So FA, this will both be FA square, 2FA square, FA will come out, FA root 2. FA is what? 18 by 25, 10 raised to the minus 3, 18 by 25, 10 raised to the minus 3 into root 2. Done? Yeah, Amaya. Yeah, I was going to tell you the calculation is a bit wrong in this. Let me tell you. Bunny, if you don't have time, if you don't want to give so much time, then you can skip it because according to the blueprint, 5 marker definitions won't come, derivations won't come from ray optics. Okay? Okay, now look at this carefully. FB, now these are 0.05 meters, right? So this will be not 0.05 meters. Let's say this is 50 centimeter. Okay, this will be 0.05 meters will be 5 centimeters, right? And this is also 5 centimeter. So this will be 25 plus 25 according to Pythagoras theorem. That is 50. Okay, that will be what? 5 root 2, right? And that will be 0.05 root 2. Done? So FB, the distance between B and V, this will be 0.05 root 2 meters. Done? Here we have used a simple 5, so you will use 5 into root 2 instead. Wait, let me correct this for you. Okay, now see, so this will be 5 root 2, oops, 5 root 2 into 10 raised to power minus 2. Now you do the calculation, now you will get correct answer. Okay, 25 into will have one more 2, right? Will have one more 2, and in here will also have one more 2, so this will be 18. So FB will also come out to be, this will not be 36, this will be 18 by 25. Okay, 18 by 25 plus 18 by root 2 into 25. Now you can just do the calculation, take that 18 by 25 out, and inside you will be left with 1 by 2, that will be 3. Yeah, sure, wait a minute. So wait, FB will be K into Q of B, Q of D divided by R square, right? Now R square we saw that it is 0.05 into root 2 meters. So R square equals to 5 root 2 into 10 raised to power minus 2 meters. Understood till here? So we'll just put the values. K into this is what? 20 into 10 raised to power minus 9. This is 20 into 10 raised to power minus 9. So this is 20 into 10 raised to power minus 9 into 20 into 10 raised to power minus 9. K we can write 9 into 10 raised to power 9 equals to divide by 5 root 2 into 10 raised to power minus 2 whole square. Right? Now if you calculate those, let us just calculate the 10 powers first. So this is 9 into 10 raised to power 9 will be cancelled with 10 raised to power 9. This is minus 9. So these two will be cancelled. So this will be 9 into 2 into, this is 110. So this will become 10 raised to power minus 8, right? And below you have this will become 1 0 here, 1 0 here, minus 9, that will be minus 7. Okay, so you can write minus 7 here, and here you have 25, 5 into 5 25, root 2 into root 2 is 2 into 10 raised to power minus 4, and we have one more 2, right? So this cancels out, this will become 18 divided by 25 into 10 raised to power minus 3. Done? Understood the calculation? Yeah, Mr. Perfect, I have asked them to send it, beta. Just wait for some minutes, maybe they are busy somewhere. I'll ask them to send again, don't worry, okay? It is added, so you can go check, okay? Yeah, I have told them. Understood? Okay, great. So now you can just add this. This is FAC, FB. FB is towards this. FAC is here. Again, they have a 90 degree. We'll do the resultant 18 by 25 square plus 18 by 25 root 2 square. Okay, 18 by 25 root 2 square. Yeah, this one. And we'll get the answer as 12.4 10 raised to power minus 4 Newton after solving. Done? Okay. Next, for numerical, two positive charges of 0.4 microcoulomb and 1.6 microcoulomb are placed at a distance of 0.15 meter apart. Let's make the diagram again. 0.4 microcoulomb and 0.16 microcoulomb. They are placed at some distance apart, which is what? Which is 0.15 meter apart. This is 0.15 meter apart, right? You have to find at what point on the line joining them the electric field will be 0. Somewhere here the electric field will be 0. Electric field will be 0. We want to find where that point will be. Okay? We want to find where that point will be. So let's say at distance x from 0.4 microcoulomb, at x the electric field is 0. So from here it will be 0.15 minus x, right? So for 0.4 coulomb, E of 0.4, we have kq by r square, that is our formula. K is 19 to 10 raised to power 9, q is given as 0.4 microcoulomb, so that is 10 raised to power minus 6 divided by x square, because the distance at this point from minus 4 is x, right? Similarly for 0.16, everything is same, the charge is different, but here the distance is 0.15 minus x the whole square. Done. So this is the formula we get. Now net electric field will be 0 when both of these are equal. This will be 0. Net electric field is 0 when E due to 0.4 is equal to E due to 0.16, because they are in opposite directions. They are in opposite directions. Done. So we will just put them in equal. So 3.6 equals to into 10 raised to power 3. 3.6 into 10 raised to power 3 divided by x square is equal to 9 into 1.6 10 raised to power 3. 9 into 1.6 into 10 raised to power 3 divided by 0.15 minus x whole square. Done. Minus x whole square. Now if you just solve this, do the calculation, you are allowed with calculators, right? We are doing the numericals, so whenever the numericals are done, I will end the session in some time, okay? We are on second numerical, I have around 15-20. Okay, Anbu, great advice. Okay, so Anbu is saying focus on the calculation. Now after this, it's just math, you'll have to solve it, okay? You just have to solve this quadratic equation, that's it. That there's not even a quadratic equation, there will be one, so you'll just solve one, okay? Next we have 2 point charges plus 2 nanocoulomb and plus 6 nanocoulomb are placed at the points A and B respectively, separated by a distance 0.2 meter in the air. Find the magnitude of the resultant electric field. We have to find the magnitude of electric field at a midpoint O. At a midpoint O of the line joining A and B, what will be the magnitude of the resultant electric field at O if plus 4 nanocoulomb is added to plus 2 nanocoulomb? So we'll see the, AC chapters will do. Wait. So we'll do the calculation. This is similar to before, so I'll just quickly explain it. Okay, you have to find at point O, the distance will be 0.1 meter, 0.1 meter, right? So you'll have to find the formula of electric field. So kq1 by r square, right? R is what? 0.1, and it is same for both. Because it is 0.2, so it is a midpoint. So this will be 0.1, this will be 0.1. So E due to 2 will also be same, just their charges will be different. This is 6 and this is 2. Okay, 2 nanocoulomb, 6 nanocoulomb. Now you just find the net electric field, that is electric field due to 6, because obviously higher charge, higher electric field, that is 6 minus 2, you'll have 3600 Newton per coulomb as your answer, right? Now if they are saying what will be the magnitude of the resultant electric field if 4 nanocoulomb is added to 2 nanocoulomb. So 2 nanocoulomb, if we add 4 nanocoulomb, that will become 6, right? So instead of here 2, you'll have to solve with 6. Right, that will be same. 2 plus 4 is 6 nanocoulomb, Q1 will be 6 nanocoulomb. So Q1 and Q2 will be same. If Q1 and Q2 will be same and in the midpoint, the electric field will be 0. Done? Okay, let's move on to the next. We have 2 opposite charged identical metal spheres placed at 0.5 meter apart attract each other. Okay, with a force of 0.108 Newton. We are given with a force 0.108 Newton when they are connected to each other by a copper wire. Now, when they are connected with each other with a copper wire for a short while, they begin to repel with a force of 0.36 Newton. Calculate the initial charges on the sphere. Okay. So we'll do in the initial case, Initial case is simple. We are given two spheres, so k into q1 into q2 by r square. K is 9 into 10 raised to power 9. q1, q2, let's just sit here because we want to find the charge. So q1 and q2 we don't know. So q1 and q2, let this remain like this. R square will be 5 into 10 raised to power minus 1 because they have told us that the distance between them is 0.5 meter, right? So if you solve for q1, q2, this becomes here and this goes down, cross multiplication, right? So this will be 0.108 into 25 into 10 raised to power minus 2 divided by 9 into 10 raised to power 9. And if you solve it a little bit, it will be 12 into 25 into 10 raised to power minus 14. Calculation you have to practice again and again. Okay? Yes, Anup, you can do it, definitely. Delulu is the salulu. Okay, next we have now the final condition. Look, for the final condition, the two spheres are connected with each other with a copper wire. So that means charge can start distributing. Charge will go from higher potential to lower potential, right? Oh, sorry, lower potential to higher potential. So current will start, the charge will go from lower potential to higher potential, right? So the both of the spheres will get equally charged. That means q1, but the other sphere they were attracting. That means one square is positive charge, another is negative charge. So this is q1 and this is minus q2. So we will add them since both of the charge are equal. So we'll add them q1 minus q2 divided by 2. Now this is the charge on each of the sphere. Okay, this is the charge on each of the sphere. So k into q1 minus q2 by 2 into q1 minus q2 by 2, so their whole square divided by the distance remains same. Now if you solve this for q1 minus q2, that is q1 minus q2 divided by 2 whole square. From here you can find this value of q1 minus q2 whole square equals to 410 raised to power minus 14. So q1 minus q2, on doing it square root, it will be 20 minus 10 raised to power minus 7. So we have q1 minus q2 equals to 20 into 10 raised to power minus 7, and we have q1 into q2. We have q1 into q2 equals to 12 into 25 into 10 raised to power minus 14. Again, this is simple math. Now, how to solve it effectively? See, q1 minus q2 whole square plus 4 q1 q2 equals to q1 plus q2 whole square. Do we all know this formula? Do we all know this trick, you can say? So you will just directly put the value of q1 minus q2, no need to open it. q1 minus q2 plus 4 q1 q2. Again, the direct value of q1 q2 equals to q1 plus q2 whole square. Now you will get q1 plus q2, you will have the value of q1 plus q2. You have q1 minus q2, you have q1 plus q2. Now from here you can easily find the value of q1 and q2. Okay? By delusion, Varun. Okay, let's move on to the next question. A conducting sphere of radius 10 centimeter has an unknown charge. If the electric field of 20 centimeter, now we are given with electric field of 20 centimeter from the center. So distance of the point is given. That means R is 20 centimeter is given. From the center of the sphere, electric field is 1.5 10 raised to power 3 Newton per coulomb and points radially inwards. What is the net charge on the sphere? This is very easy, okay? I want Q1 into Q2 equals to 3 picocoulomb, ma'am. Okay, Amaya, great. Just solve it and write the answer there, okay? You should get scared, Anoop. This is perfectly fine emotion for you. Okay, so E equals to minus KQ by R square. We know that, right? And Q will be minus ER square by Q if you rearrange it. Now E is given, R is given, E is given 1.5, R is given 20 centimeter, K we know, but convert the R into meters first. So 20 into 10 raised to power minus 2. Done. Now just the whole solution you can do. Okay? Okay. Next we have your Electric potential and capacitance, very easy, you just given the values, put that in the formula. These are all model question paper questions, pre-board questions, PYQ questions, so you can see that you just need to remember the formula, everything else will do. Okay. Yes, higher potential to lower potential, the current will move. The PDF is added, guys, 2 to 3 markers that I took in the morning. The PDF is there, you can go check that out. Okay, there is a link in the description, go join that and check that out. Okay. Okay, in a parallel plate capacitor with air between the plates, each plate has an area of 6 into 10 raised to power minus 3. So A is given, right? A is given, and the distance between the plates is 3 mm. D is also given. Calculate the capacitance of the capacitor. We have to calculate the capacitance. If this capacitor is connected to a 100 volt supply, we have V as 100 volt supply. What is the charge on each plate of the capacitor? So how you will start with? You will start with, of course, capacitance epsilon naught A by D into K. Now for air, K is equal to 1. So we have the formula epsilon naught A by D. Epsilon naught is 8.84 10 raised to power minus 12. A is given, that is 6 into 10 raised to power minus 3. And D is given, that is 3 into 10 raised to power minus 3 meters. It was in mm. Okay. So when you solve it, you will get 17.7. Oops, sorry. You will get the answer as 17.7 into 17.7 picofarad. Okay. Now in part B we have to find V. We are given with V, we need a total charge. So Q equals to V into C. Q equals to CV, right? So C, we just find out V, it's given 100 volt. Just multiply these two and you'll get the final solution, that is 1.1 into 1.77 nano coulomb. Done? Done. Okay. Next we have calculate the potential at point P due to a charge of 400 nanocoulomb located at 9 centimeter away. Located 9 centimeter away. You just have to find the potential. Direct formula, KQ by R. K is 9 into 10 raised to power minus 9. Q is given as 400 nanocoulomb. So it will be 10 raised to power minus 9. R is given as 9 centimeter, 10 raised to power minus 2 meter. So this you calculate. This is the A part. Done. B part, obtain the work done in moving a charge of 2 nanocoulomb. Now you have a charge of 2 nanocoulomb from infinity to point P. Does the answer depend on the path along which the charge is moved? Now work done is simply V into Q, right? So Q we have 2 nanocoulomb, 2 into 10 raised to power minus 9. V we calculated 4 into 10 raised to power 4 and its units are joule. Do not forget to write units, my friend. Okay, so if you solve this, you'll get 80 microjoule. Now they have asked, does it depend on the path? So it does not depend on the path. It is independent of the path because electric field is conservative. Done? Oof. Everyone understood? Any doubt till here? Okay. Let's move on to the next. We have capacitance of a parallel plate capacitor is 1 nanofarad and the plates are separated by 2 mm. So C is given, D is given, find the area, you can find it. Okay, you can find it. Great. Next we have two charges of 10 microcoulomb and 5 microcoulomb are 12 centimeter apart. Find the work done in bringing the charges 2 centimeter closer. So first their distance was 12 centimeter. Now their distance is 10 centimeter, right? We moved it by 2 centimeter. So the distance is 10 centimeter now. So our initial was 12 centimeter. Our final was 10 centimeter. So U initial are okay, to find the work done, we can find KQ1, Q2 by R. That is difference in potential energy, right? difference in potential energies. So 9 into 10 raised to power 9 into Q1 is 10 into 10 raised to power minus 6 into 5 into 10 raised to power minus 6 divided by the distance between them initially is 12 centimeters. So 12 into 10 raised to power minus 2. You solve this, you get an answer 3.75 joule. Then final energy will be similar, but the distance is different. Here we have 10, here we have 10, here we had 12, right? So that is the only difference. You will get 4.5. Now what is the work done? Change in potential energy, change in energy, that is U final minus U initial, and your answer is done. Okay, let's move on to the next. We have two capacitors of capacitance 2 picofarad, 4 picofarad connected in parallel across 100 volt supply. Two capacitors connected in parallel. Now what is the total capacitance? Oh, this is very easy. In parallels we know capacitances directly adds up. So this is C1 plus C2, 2 plus 4, 6 picofarad. Done. Now determine the charge on each capacitor. So for Q1 you have C1 into V because voltage remains same in parallel. So C1 into V, that is C1 is 2 into 10 raised to power minus 10 into 100, that is your voltage. Similarly for Q2. Again, the simplest question, but was a repeated one, was a model question paper. It was a very important question. Okay. Now, next question we have a 100 microfarad capacitor is in series with a 40 ohm resistance, is connected to a 110 volt supply with 60 hertz. What is the time lag between the current maximum and the voltage maximum? So for that we have to find the phi. Phi for capacitance and resistance is this, phi equals to tan inverse XC by R. Now for that we need XC, right? So XC is simply 1 by 2 pi F into C, 2 into 3.4. Now F is given 60 hertz and C is also given 100 microfarad. So you can easily find XC. Now XC came out to be 26.6. right? And R is 40 ohm. So finding phi will be easy. Phi is tan inverse XC by 40. So that is 33.5. So there is some lag. So if XC is greater than XL, that means I is leading the voltage, which is the case here. So here you will say that maximum current is leading the maximum voltage by 33.5 phase difference. Okay. Hi Sahana. Okay, next, this is almost the same. An AC source of frequency 50 Hertz, we are given with an AC source of frequency 50 Hertz is connected in series with an inductor of 1 Henry. So we have L as 1 Henry, of course, and capacitor of 90 microfarad and a resistor of 100 ohm. Does the current leads or lags the voltage? Calculate the phase difference between current and the voltage. So to find the phase difference between current and the voltage, we have that as well, inductor as well, right? So this is the formula. Phi equals to tan inverse XL minus XC divided by R. So we'll find XL, that is 2 pi F into L. 2 is given, pi is given, 50 Hertz is given, L is also given 1. So this is your answer. XC formula is 1 by 2 pi into FC. So this formula is given, we just did it. This is 35.39 ohm. All this is calculation. So you just see how to do these numericals. Okay, how to approach these numericals. Okay. Hi Tapu. Okay, so in here we can clearly see that my XL, the value of XL is greater than value of XC. That means the current is leading. Done? Oh, sorry, lagging. The current is lagging. Done, everyone? So to find tan inverse for the value, we'll just put 314 minus 35.39 divided by R, that is given as 100. So this is your phase difference. Okay? Okay. Let's move on to the next question. We have a sinusoidal voltage of RMS value 200 volt. So we have an RMS value of in which R equals to 3 ohm and C equals to 800 microfarad. For impedance, we need to add these two, right? Oops. Yeah, it's working. I was seeing if the live is working or not. Yeah, so for XC, we have the formula 1 by 2 pi FC. So 1 by 2 pi FC, you have F, you have C, calculate everything. And then impedance will be what? R square plus XC square. So you find impedance, that is 5 ohm. Done. So we had to find calculate impedance of the circuit. That is how you find impedance of the circuit. Right? Then the current through the circuit. Part B, current through is simply what? V equals to IR, Ohm's law. R here is what? Impedance. So I equals to V by Z. V is given 200 volt. Z we just found out 5 ohm. So it comes out to be 40 ampere. Okay. Next we have part C, phase difference between current and voltage. That is simply XC by R, tan inverse XC by R, tan inverse 4 by 3, 53 degrees. Done? Understood? Okay. Let's move on to the next 14th question. Again, very important, very easy. For a series LCR circuit with L as 0.5 Henry, C is 8 microfarad, R is 10 ohm, if the applied RMS voltage is 50 volt. So we are given that voltage is 50 volt and the resonance, find the resonance frequency. We have to find the resonance frequency. So for resonance frequency, we know the formula 1 by 2 pi root LC. This is clearly 1 by 2 pi root LC. Just put the values, do the calculation and the answer came. Do not forget to write the units. Okay. Then we have what is the average power dissipated. To power is V square by R, right? Because voltage is given, current is not given. Voltage and R is given. V square by R, that is 50 into 50 divided by 10. Done? Any doubt, anyone? Any doubt you have? Okay. Next question, we have a sinusoidal voltage of peak. It is again the same. So I am giving it to you to do. Okay. This is exactly the same. So, voltage is given, series LCR circuit in which resistance is given, inductor of inductance is given, capacitance is given, find the resonant frequency, again the same formula. Then you have to calculate the impedance and power dissipated, again it is same. Just the value of voltage is different, everything else is same. Impedance at resonance, impedance is equal to R. Z is equal to R, that is given as 5 ohm. So this is V square by Z, 220 volt square by 5. Okay, great. Next we have an object placed at a distance of 40 centimeter. So we have U as minus 40 centimeter from a concave mirror. So concave mirror is given of focal length 15 centimeter. So whenever you get a mirror, first find out the sign of focal length. So for concave mirror, focal length is negative. So this is minus 15 centimeter. If the object is displaced through a distance of 20 centimeter towards the mirror, how much distance is the image displaced? So we technically have to find the image distance V1 and V2 first without displacement, after with displacement, right? So we'll simply use mirror formula. In first case, we know the mirror formula is 1 by F equals to 1 by U plus 1 by V. If you want to do this calculation, you can do it. Either you can directly put the value in this as well, like 1 by where V we have to find, right? So 1 by F minus 1 by U, 1 by F is minus 1 by 15 minus of minus 1 by 30 or 40. As such you like, whatever you like, you can do it. So if you can find the value of V from here, right, V1. So V1 will be simply the solution of this. Or you can find this formula here, then you can put the values as well. Whatever you want. Okay, then in second case the object is displaced by 20 centimeter towards the mirror. So first u was minus 40 centimeter, now u is minus 20 centimeter. Again use the same formula, fill all the values, find v2, and then we'll see this is minus 60 centimeter, this is minus 24 centimeter. So v, the image is displaced away from the mirror, right? So minus 60 minus of minus 24, that is minus 36 centimeter. Okay. Okay, let's move on to the next question. An object is placed at a distance of 0.3 meter. So u is minus 0.3 meter from a convex lens of focal length 0.2. Now in convex lens, focal length is always positive. Okay, find the position and nature of the image formed. We have to find the position and nature of image formed. First, find that. Again, you want to do this calculation and reach to this final formula, you can do that, or you can simply put these values of u and f here as well. Okay. If you solve for the value of v will be simply 0.6 meters. The image, see, in convex lens, we know either of the sixth case, except sixth case, why negative value is not positive? Where? Where are you asking, Dhanush? So in here, for convex lens, we know except the sixth case, all the images, all the nature of the images will be real inverted, right? So here we can definitely see it's not the sixth case because object distance is more than focal length. So it is not the sixth case, the image will be real inverted and it will be magnified. You can find the magnification v by u for lenses. V is 0.6, u is minus 0.3, and this comes out to be minus 2. So it is real inverted and magnified. Okay. To get a magnification of minus 1, 1 means the size of the image is same, the object distance and image distances are same. So we have to place the image at 2f, the object at 2f. So u equals to 2f, u will be minus 2. U is, where did we saw u? U was, the object distance is at a distance of 0.3 from a convex lens. To get a magnification minus 1, we need to place the object at u equals to 2f. But u here is 0.3, right? So 0.3, it will be 0.3, 0.6 meters. Okay, and from here 0.6 minus 0.03, that will be 0.3 meters. Okay. Okay, everyone, done? Understood? Yeah, for MCQs, 3 model question papers are enough, but you have time, you do the question bank as well. Okay? Do the question bank as well. Fine? Oh, my mistake. Here we will have 0.2 as well because u equals to 2f, done. It is f, I was placing the value of u. So 0.2, that is 0.4, the answer will be 0.1 meter. Yeah, I did a little bit of mistake. Magnification, we need u equals to 2 into f. So f we have, right? F we have 0.2. So u equals to 2 into 0.2, that is 0.4. Now, what is the change in position of the object? For the object to be made of magnification 1 or minus 1. So, minus 0.4 minus 0.3, that is 0.1 meter. Okay? Okay. Next, we have another question. We have, at what angle should a ray of light be incident on the face of a prism of refracting angle 60 degree so that it just suffers total internal reflection at other face? The refractive index of the material of the prism is 1.524. Right? Very simple. How you have to go through this? See, as this ray is bending and we have I and R, so the first thing you need to think is I have to use the Snell's law. So I, that is N1, this is N1 into sine of I equals to N2 into sine of R. This is 1, the prism refractive index is, let's say, N. So from here, this is my critical angle, right? So N into, now this is the first phase of prism. First phase of prism, right? Now in the second phase, now this is for this ray, right? N1 into I equals to N2 into R, N2 into sine R. Now when the light is refracting on the second phase, here it is making critical angle, okay? So N1 into IC or N into IC will be equal to 1 into sine 90, because sine 90 is the maximum deviation it will get at critical angle, okay? So these two things you need to remember, 90 and sine IC. So N sine IC equals to 1 into sine 90, sine 90 is 1, so sine IC will be 1 by N. Then from here IC is sine inverse of 1 by N. N is given 1.524. Put that here, solve it, and you'll get IC equals to 41 degrees. Right? Now we have to find the refractive index of the material. To find the refractive index of the material is given, we have to find what? At what angle should a ray of light be incident? We have to find I. Right? We have to find the incident angle, this one. Now for that, let's go back to sine of R. Let's go back to this angle, right? Because in this equation only we have sine of I, and we want to find sine of I. So sine of I equals to N of sine into R. N of sine into R. Okay? One. You will have calculator, right? In the exam, it's allowed. So in that calculator you can find inverse values, or most probably you will have those log tables, you have those, so they'll give you. Chitra, do not miss your, what do you say, explanation and derivations, because explanations are the main part of derivations, so your marks will cut. Let's say if you have 5 marker derivation, at least you might get, it's on the teachers, but you'll get 2.5 or 3 marks maximum. Okay, if you don't do the okay, let's just quickly finish it. So sine I, you just put all these values, just see how to find the R value here, okay? So R is, we know from our derivations that A is equal to IC plus R. So A equal to IC plus R. Now IC we have A is given, that is 60 degree. So I we can find 19 degree. So I equals to sine inverse into 1.524 into sine 19. This was sine R, right? So you can find this value. Now inverse values you can find using log tables and all. Shreya, the PDF of 2-3 marker questions is available. You can go, there is a link in the description, go to that WhatsApp channel, it is given. Okay? The main explanation is simply whatever they asked you. If they have asked you about capacitors, so write about capacitor. If they asked you about derivations, we did so many derivations. So just explain that what is happening. What if they are given in the question, just explain that, okay, we have placed a charge, another charge is doing, we will calculate work done. That is it. Okay? See, my electron is running inside the conductor, but it is simply colliding, right? So I can't say electron travels with almost speed of light. So from there to there, why do we take, it takes so much time to travel? It should travel in like less than 1/1,000,000th of a second, right? So that is why the concept is drift velocity. Electron travels with drift velocity, means they are continuously colliding with other electrons, with atoms, with walls of the container. So the net velocity that comes out is called drift velocity. Okay? Okay, that is it for this lecture, everyone. We did all the numericals, we did all the derivations that was important for you. And all the best for your exam tomorrow. After this, Soumik sir will be coming live, so join that and make sure you do all these numericals and derivations. I will provide the PDF of these, okay? Okay, bye everyone. No, you have to write the explanation. The only derivation won't be enough if you want to get full marks. Okay, bye everyone.